Okay, so
No, sir.
surely, okay. So essentially, we have completed your Ansible. The last part that I have that I want to talk about is your the UI side of your Ansible. So see, until now we have looked at how we can work with your Ansible using the CLI version, right? So using the CLI commands. Now Ansible also has the option of using the UI version, like a web-based user interface version. Now Ansible, it provides you this tool called Ansible Tower, which is the UI version of your Ansible. Okay, so this is your web-based user interface that we can use for Ansible, and this is also developed by the same company. So, do you know which company, as of now, which company maintains Ansible? Do you know that?
No, sir.
No, Ravi.
So it is Red Hat.
Okay.
Okay, so the Ansible Tower is also provided by your Red Hat. So this Ansible Tower, it simply provides you with an easy to use dashboard, and you can also control the access by making use of your role based access control. So with this, it becomes easier to allow individual teams access to your Ansible Tower, which they can start using for their deployments. Now, what's the advantage of this? With this, the teams, they don't have to rely on you to do the deployment. So you can do all the work, all the automations and everything, and then the other teams, they can do the deployment whenever they want without depending on you. Okay, so that is where the whole point of having your web-based tool was introduced. Now this Ansible Tower, I would say like an year ago, we had a free option, but now they have moved. They have gone with a subscription option. So they still give you a 3 month free subscription, but post that you'll have to pay money for that. But essentially, how does your Ansible Tower look like, if you ask me? So it would be something like this. Okay, this is the home page. When you set up your Ansible Tower, it will look something like this. It's not really clear, but let me see. Yeah, okay, so something like this. Okay, so here you will have like your host, your projects, your inventories. Here you can define your different jobs. All those things can be defined. So it is simply the UI version of your Ansible. Now you also have one more tool called AWX, which is a free version of your Ansible. Okay, so if you're interested to set up your, you want to set up a UI version of your Ansible, you can go ahead and make use of this AWX, which again provides you with a web-based interface that you can use with your Ansible. Okay, I'm not gonna cover this section, but it's just an FYI that you also have a UI version of this which is available. Okay. Any questions? That's basically all I have as part of your Ansible. That completes it.
No, Ravi.
Okay. So the next tool that we are going to start off is your build tool. Okay. Any idea what is a build tool?
No, Ravi.
No, sir.
Okay. So let's say you want to install Skype on your Windows laptop. So what do? We go to the browser, we search for Skype, we look for the exe file, we download that exe file, we run that exe file, and we get the application. Yes.
Yes, Ravi.
Now that exe file, how do you think that takes care of everything? So with your exe file, if you see, you don't have to worry about the code, right? You don't have to worry about the dependencies. As a user, you don't have to worry about anything. You just double click on the exe file, and that takes care of installing the Skype application on your machine, right? So packaging is, or sorry, build tool is simply packaging your application into a deployable artifact. Skype in this case. See, it is all code in the backend. As a developer, we would have written lots of code for that. But as a user, you don't have to worry about all those things. You just run the package gets deployed, you get the application. So if you want to convert your application code into a deployable package, into a deployable artifact, we make use of your build tool. So any application you take, for example, you install WhatsApp on your phone. That's your APK package. If you're on Mac OS, you'll have the .dmg package. If you're on Ubuntu, you'll have the .deb package, .rpm package, right? So to create your packages, we make use of your build tool. So to create your deployable packages, okay, or your artifacts, we make use of your build tools. Does that make sense?
Rabbi, is Docker a build tool then? Because Docker is used to package the application code and all its dependency, right?
In a way, yes.
Okay.
Okay. That is also used to create your packages and everything. But the difference with build tool you see is that you just get the artifacts, that's all. And then you take those artifacts and you'll have to manually deploy them on the individual machines. Could be your test servers or could be your prod servers.
Rabbi, I see this word artifact in my company Slack channel also. So what exactly is artifact?
So it's just a term that we use for packages.
Packages, okay.
So, yeah, people are generally, you don't see people calling them as packages. We call them as artifacts, which is nothing but telling that, hey, we have created this particular package.
Okay, got it.
Now, when we talk about your build tools, obviously we have lots of build tools. Okay. When we talk about your Java applications, we have Maven, we have Gradle, we have Ant, we have MS build, we have Quick build, we have NPM, we have PyBuild. Likewise, you have lots of build tools. So depending on the programming language that you're using, your build tool will also change. So if you're using Python, you'll have PyBuild. NPM is for your Node.js applications. Quick build, MS build is for your Microsoft applications. And is again for Java application. Gradle is for your Android applications. Maven is again for your Java application. So based on the application that you're working, based on the programming language that you're working on, you have different build tools. So in my project, we're using Quick build to build our artifacts. So in our case, we are going to look at your Maven, which is the build tool. Now, essentially, you don't have to really worry about your build because it is always taken care by the development team. But still, you should be knowing about it to a certain extent. Okay, how your build works, what is the process, and all those things. It's important. So, like I said, in our case, hold on, sorry. So in our case, we are going to look at your Maven. Yeah. So your Maven build. Okay, let's first talk about your build tool, right? So build tools, like I said, these are commonly your programs which can be used to automate your build process. So when I say a build process, basically converting your source code into an executable package. So as a developer, we will write the source code. But as a user, it really becomes difficult if you ask the user like, hey, this is the source code, start using the application. See, as an end user, think of it like this. You have a car, right? The manufacturer will tell you like, hey, these are the different parts of the car. Go and drive it. Now, like think of it as they give you the wheels separately, they give you the engine separately, they give you the steering, they give you all the different components separately. And then they tell you, hey, you can use this to drive, you can use this to move around. Now think of it from an user's perspective. The same applies to your application as well. When we talk about your application might have configuration files, it might have certain dependencies. There are different components always, right? Now, as a user, we'll have to bundle all this together, right? Like your car, we have to assemble everything together. Only then it will be useful for the users, right? The same applies to an application. We need to bundle that into an executable package. So as a customer, all I have to do is insert the key in the car, turn it, and the car should start. Likewise, when I click on the executable package, it should start installing it. I don't want to do anything else. That's where we make use of your build tools. So this building process, it includes your compilation, your linking, your packaging, everything will be taken care by the build tool. So build automation, it's simply the process of automating the retrieval of your source code, compiling that source code into binary, executing any automated tests, and then publishing that package to a shared centralized repository. So all of these things should be taken care by your build tool. So right from picking the code, compiling that code, running tests, and then pushing that package to a shareable location. All these will be taken care by your build tool. So when we talk about your build tools, like I said, so we have your Lenin, we have Apache and Gradle, Maven, Gulp, Grunt. All these are your build tools. So in our case, we are going to look at your Maven. So Maven is commonly referred to as a build tool that can be used to manage your entire life cycle of your package project. And I say that, pulling your code, compiling it, testing it, packaging, everything will be taken care by the build tool. All right. So using this Maven, we can build it, we can create executable package of your application. All of these things can be done. So the code written by your developers must be packaged and converted into an executable format. And this can be done with the help of your Maven. So let's say you have a big application, right? Think of it as your e-commerce application. So you'll have the login code, you'll have the security code, the payments code, the emailing code, the live chat. So all of this, the different components. Now, I want to bundle all this together such that when my users start using this application, the bundle, the package, the artifact will have everything. This can be done with your Maven. So since Maven is a build tool, it can help in building an application that has different modules. It helps doing so by downloading all the dependencies, maintaining a folder structure, and then building an executable with all the dependencies. So when I say dependencies, let's say we're talking about your Java application. So we have dependencies like Hibernate. If it's your Spring Boot application, Spring is a dependency. If you want to capture your logs, Log4j is a dependency. So your Maven will take care of all those dependencies. Also, it will maintain a folder structure. So every time you create a new project, it will have the same folder structure. What I mean by that is it will use the same location to create the artifacts. It will use the same location to run your test cases. So the folder structure is standard. And then finally, it also helps us to build an executable, the package for including all the dependencies. So all of these things will be taken care by your Maven. So what does your Maven do? Like I said, it maintains a folder structure. It manages all the dependencies and then creates an executable from the application code. Everything is taken care by your Maven. So let's talk about your dependencies, right? So the project that you're working on, it may need certain dependencies, which can be your Java API or frameworks that are packaged in their own jar files. Now these jar files are needed in the class path when a project code is compiled. So what your Maven will do is, so let's say this is our project where we have the application code. So when I'm trying to build this, there will be a pom.xml file where we give all the details of your dependencies. Now what Maven will do is Maven will read this pom.xml file, get the details of all the dependencies, go to the internet, search for the dependencies, download the dependencies and give it to the project. All of these things will be taken care by Maven. You as a user don't have to worry about any of those things. So that is where a Maven tool is a build tool is really important. So let's talk about your pom.xml file. Now this pom.xml file is a very important file in terms of Maven. Okay, so this is simply the configuration file of your Maven. It's a way for us to give instructions to Maven as to what dependencies you want, where you want to push the package, what custom tasks you want to do. All those instructions we can give in a pom.xml file. So every Maven project that you're creating will need a pom.xml file. So if you have 100 Maven projects, you'll have 100 pom.xml file. So this file will contain all the details necessary for Maven to create your package. All right. And generally this POM file is stored in the SRC or in the root directory. So, if you're talking about the application, so let's say, let me go here and I'll show you a sample example. So this will be your root. Okay, and here you can see you should be able to see the pom.xml file. So here is an example of your pom.xml file. So you'll have the group ID, the artifact ID, the version, the packaging, then properties, the dependencies. All these information will be available in your pom.xml file. Okay, so it's a main configuration file. Just hold on a minute. Sorry. Okay, guys, I'll need 10 minutes. My son is crying, so just give me 5 to 10 minutes. I'll be back. Is that okay?
Sure, Rabbi. Sure. Take your time.
Thank you. Come back, guys. Thank you and sorry. Okay. So, any questions or any queries until here? So we have discussed until your pom.xml file.
No, Ravi.
No, sir.
Okay. So let's look at your Maven architecture. So see, like I said, what will happen is you'll have a project directory. Okay, like in this case, if you see, I have a project folder. So under this source, if you see, I'll have the file. So I'll have the web.xml index.jsp. So basically, this will be my application code. And for each of this, you'll have one pom.xml file. You can ignore this Jenkins and then Docker files. This pom.xml file is what you'll have. Now, this is where we give all the details as to what do I need for building this application. What do I need? I'll give all those details. So what Maven will do is Maven will read the pom.xml file, get all the information about the dependencies. It will go to the internet, search for those dependencies, download the dependencies, and then give it to the give it to the application. In this case, for example, if you see this dependencies, I've given JUnit, the version. So what will happen is my Maven will go to the internet, search for that JUnit dependency with that particular version and download it to my local machine. The next time, if I want to use the same dependency, it will simply reuse that dependency. It won't download it again and again and again. It will download it only the first time. So basically, it will check in the local machine first whether the dependency is available or not. If available, it will simply reuse that. If not available, it will go to the internet, download that, and then reuse it. That's how. So the same how your Docker works. The same way your Maven also works. Make sense?
Yes, Ravi.
Now, let's talk about your Maven build lifecycle. So, there are different steps when we talk about building an application, creating a package. So, a build lifecycle, it is simply a well-defined sequence of phases, right? And each of these phases will have a goal that needs to be executed. So here, your phase, it simply represents a stage. So a typical Maven build lifecycle, it consists of the following sequence of phases. So you'll have the validate. So first step is to validate whether your application has everything or not. Then compile it, then test it, then package it, then verify it, then install it on the local machine, and then deploy, which is push it to a central repository. So generally, these are all the phases you will have. Now, it's not necessary that you should have all this, but generally speaking, build process will include all these steps. So let's talk about each of these phases one by one. So what happens in the validate? So validate phase is where your build tool will validate whether the project is correct or not, whether the folder structure is correct or not, whether all the necessary information is available or not. So all those validations will be taken place in your validate step. Once the validation is successful, it will move on to your compile phase. So compile phase is where your application code will be converted into binaries which your computer can understand. So during the compile phase, Maven will compile all of your .java files present in the main directory into .class files and put them back into the main directory in the dedicated folder. So your Maven will go to the main directory. It will look for your .java application files. It will compile that by converting into .class files and then again put it back into the main directory. So basically converting your code into machine readable code which your machine can understand. That's your compilation phase. Once that is successful, it will go to the test phase. So see, generally when we talk about your testing, we have something known as your unit testing. That unit testing will be part of your build process. The same thing we do here also. So during the test phase, if you have defined any test cases, Maven will execute those test cases and also it will maintain a log. How many test cases were executed, how many passed, how many failed, all those summary log will be maintained as part of your testing phase. Once that is done, it will go to the package phase. So this is where your package will be created. So during this package phase, Maven will package all of your .class files and resources into one single file. So basically all the different components will be combined together into one single package. Now in Maven, there are three types of packages that we can create. We have the jar, we have the var, we have the EAR. So generally jar is for your desktop applications, var is for your web application, EAR is for your enterprise applications. So here, for example, if you see in this form.xml file, I would have defined my packaging. So here, if you say I'm telling var, that means I'm telling that I want to create a var package. Likewise, you can create an EAR package, a jar package. So these are three types you have. Then comes your verify phase. So it runs any checks on results of your integration tests to ensure the quality criteria are met. At the same time, all the previous lifecycle phases were also executed successfully. So all those verifications will happen. Once that is done, it will move on to the install phase. So install phase is deploying that package on the local machine, or rather storing that package in the local machine in the local repository. So install the package in the local repository for use as a dependency in other projects locally. All previous lifecycle phases are also executed. And then finally comes your deploy phase. So if you want to push that package to a common location, like let's say a shareable repository, we go with your deploy phase. So it copies your final package to a remote repository for sharing with other developers and projects. So these are the different phases we have. Questions?
No, Ravi.
So like how with your Git and GitHub, we had your repositories. In Maven also we have your repositories. Okay, so after Maven understands which all dependencies are needed from the pom.xml file, it will first check. So here also we will have two types of repositories. We will have the local repository and then we will have the central repository. So whenever your Maven is looking for a dependency, so we will define that in the pom.xml file. So Maven will read this and first it will check. Because just give me 1 minute, sorry. Sorry, so Maven will first check in the local repository whether those dependencies are available or not. If the dependencies are not available in the local repository, then it will go to the central repository, search for the dependencies and download it to your local repository, so that the next time if you want the same dependency, you can simply get it from the local repository. So there are two types of repositories in Maven, the local repository and the remote repository. The local repository is generally on your local computer. So Maven will first search this local repository before going to the central repository. So you can think of your local repository as your local cache, right? So I'll be showing an example for this later on. And then you have the central repository. So by default, Maven will search Maven's central repository, and you need internet connection for this. Once the files are downloaded, they are stored in the local repository. So this is the default central repository, search.maven.org. Okay, so this will be your repository. Now you can search for the dependencies here. So let's say, for example, Hibernate. So you should be able to see all these Hibernate dependencies. Likewise, let's say we're looking for Spring. So you'll find all the Spring dependencies. Likewise, let's say log4j. You'll find the log4j dependencies. Likewise, JUnit. You'll find the JUnit like this. Any dependencies you want, it will search in this central repository and then download it to your local machine. Questions?
No, Ravi.
All right. So let's look at how you can install your Maven. So again, installation is pretty simple. You just have to run few commands which will install Maven for you. So let me start this machine and I'll show it to you. You requested more vCPU capacity. Okay, that's interesting. Okay, anyways, it's okay. I'll use this only. Now your Maven, it depends on Java. So the first thing you'll have to do is you'll have to install Java on your machine. Wherever you want to install Maven, you have to make sure that you have Java. So in my case, we don't have it. So we'll go ahead and install this. So I have to install, let's go with 17 JDK. And that should install Java for me. Once you have Java, you can install your Maven tool. Okay, so let's wait for this to complete. Okay, so now let's validate. So Java-version, and there's my Java installed. Post this, you can install your Maven. For that, we can simply use this apt install Maven. That should install the default version, but if you're looking for a specific version, then you'll have to manually download the binaries and then install it. But I mean, installation is pretty straightforward, just a couple of commands and you should have. Now to work with your Maven, we have this short form called MVN and then MVN version, and you can see there's my Maven installed. So the version of Maven home directory, what version of Java it is using, what OS it is, all this information will be available. That's your installation. Any questions?
So,
Ravi, do you have to set local repository?
No, you don't have to do anything. Maven will take care of that automatically. So what happens is once you install Maven, the local repository by automatically, all right, the local repository will be available in your root folder. Okay. So there should be a yeah, as of now I don't have it, but there should be a dot. I mean, once you start downloading the dependencies in the root folder, you should be able to see a .m2 folder, which is your Maven. Inside that, all of your dependencies will be stored automatically. So if you're on your Windows machine, in your C drive under users, your username, you should be able to see this .m2 folder. That is where all the dependencies are stored automatically.
got it, Ravi.
Okay, I will stop here. So tomorrow I will show you an example of this. Again, I'm not going to go in depth in this. This is, just so you understand what is a build process, why we have it, and how it works. That's all. I'm not going to go in depth in this. This is just for you to understand the process of it. That's all. Okay. So tomorrow what we will do is we will create a simple project. I'll show you how you can do that. We'll push the code to GitHub. And we will deploy that code to a Tomcat server. Okay, so basically how we can build the package and then how we can deploy that and then how we can access it. I will show that. Pretty much that's all you should be knowing when we talk about your build. Like I said, there's a different team that will be taking care of this, but you need to understand the process. So that's where I'm just touching on this particular tool. Okay. Tomorrow, will you guys be available for the session?
Yes, Ravi.
Yes, sir.
Okay, so tomorrow we'll continue. So I'll complete this tomorrow. And then if you have time, we'll start off with your Jenkins, which is a very important tool. So, we will look at that. All right.
Sure, Abhi.
Thanks a lot, guys. I'll see you tomorrow. Thank you so
Thanks,
much.
Abhi. Take care.
Thanks.
Yeah. Bye.